Now we will look at a question based on reflection from spherical surfaces. So the question says, a thin rod of length f by 3 lies along the axis of a concave mirror of focal having focal length f. One end of its magnified image touches the end of the rod. The question is, what is the length of the image? So this is a question in which we are dealing with a concave mirror. Earlier we were dealing with refraction from spherical surfaces. This one is a question based on reflection from spherical surfaces. So let us draw the diagram for this question. The key point over here is that the question says that the image is magnified. So in a concave mirror, magnified real image, so to say, so real magnified image happens when the object is between f and 2f, where 2f is also approximately equal to the radius of curvature of the mirror. So this is the case for a real magnified image from a concave mirror. The next important point says that one end of the image touches the end of the rod. So this means that the image of one end of the rod coincides with itself. This happens only when the object and image both are when the object is placed at 2f, so the image is also at 2f. So for object and image to coincide, the object and its image coincide only when object is at 2f. So these are two important points to note before we start. These will help in drawing the diagram and subsequently solving the question. So where the real magnified image is formed and where the object and image coincide. So now let us draw the diagram. This is a concave mirror. This is the axis This point is the focal length. This point is twice the focal length. This is also the center of curvature, because 2 times focal length is the radius of curvature. So this distance right here is f, and this distance is 2f, which is also approximately equal to r in the paraxial regime. So now let us draw where the object would be positioned. So we know that the object needs to be between f and 2f, and also one end of the object has to be at 2f. So our object would be placed somewhat like this. This is a rod, and the image would then be formed over here. So note that the object would be magnified and also a little bit distorted. Sorry, the image would be a little bit distorted. This is because this length over here is at 2f, so this will be of the same length, but the other end of the rod is between 2f and f, so that will be magnified. As a result, the rod will be of a little bit distorted shape. Now we need to find the length of this rod. The length would be this length we want to find out, given that this is f by 3. So we will use the mirror formula. Mirror formula is as follows. This is the mirror formula. Now we know that one end of the rod, the end at 2f, is imaged at the same location, because if the object is at 2f, then the image is also at 2f. So we know that one end of the rod is at C. So C, one end of the rod for both object and image. Now we need to find out the location of the other end of the rod. So if this other end is at A, then we need to find out where it is imaged at A prime location. So we want to find out this point, which is having coordinate A prime. So let us now see what our U for A is. So we want to find out A going to A prime, the location for A prime. For this case, our object distance U is this object distance right here. So this is U, and this would be our V. So magnitude of U in our case is 2f minus f by 3. So U is this length and this is 2f minus the length of the rod, which is f by 3. So this is 5f by 3, and from the sign convention, u is minus 5f by 3. So plugging this u in this mirror formula, this is the mirror formula, spherical mirror formula. Plugging in this value of u, we get the following. Rearranging the terms, we get the following. Note that in our case, this is a concave mirror, so the focal length is also minus f from the sign convention. So we have found out the image location. Note that I had made a small mistake over here. So this is the spherical mirror formula. 1 by f is equal to 1 by v plus 1 by u. Now in this, f, v and u need to have the proper sign based on the sign convention. So in this setup that we have, u and v both are negative, and so is f. So even f in this setup, according to the sign convention, would be negative. So this is v that we have found out. Now length of the rod, of the image of the rod, length of the image of the rod is going to be equal to, so this is mod of v minus 2 times f. So it is this distance minus this distance, that is the length of the rod. This is the length of the image of the rod, L. So plugging in the values, we get L equal to 5f by 2 minus 2f, which is equal to f over 2. So we have found out the value of the length of the image of the rod from this question. This was a question on reflection from a concave mirror. For solving this question, we used the spherical mirror formula, and we need to be very careful in using the sign convention. I had made a small mistake over here earlier, so all of you should be very careful in using the sign convention. So the important takeaway from this question was this spherical mirror formula and using the sign convention properly.